Hello everyone. What a hiatus. Didn't do this yesterday. I was swarmed yesterday. Alright, so we're gonna do today. So two things. First, we're gonna do the challenge, which is which actually is not that difficult. I mean, I already see it. It's an easy one, so I'm gonna do that. And after that, I'm gonna revisit the contest, the ones we had on Saturday. The one that I know how to solve, but I got TLE like what, 5 times, so it's pretty ridiculous. So I'm gonna go back to that one, and we'll call it a day. And I'll do another one tonight. All right, let's see. Richest customer, Wells. Oh, it's a new problem. Ah, very rarely. You're given a n by n integer grid. Integer grid. I was thinking about matrix. I had issues yesterday with matrix to figure out how to do PCA and how the PCA and SVD single value decomposition can relate to each other, and I wasn't able to get the connection right. Anyway, yeah, it was a struggle, and I also wasted a lot of time trying to use MATLAB for this. Like, what am I kidding? I cannot do MATLAB. It's a new learning curve. It's a necessary learning curve. Python is good enough. Maybe one day I have to use MATLAB. All right, again, back to this. Accounts IJ is the account of money the ith customer has in the jth bank. Ith customer in the jth bank. So I is the rows. J is the column, okay? Return the wealth that the richest customer has. Oh, the wealth, I just want to find the sum of the rows, right? Maybe I can, I think they have NumPy on this. Wait, do I have NumPy? Let me see. Maybe I do. Oh, maybe I do, maybe I don't. No, I don't think so. I don't think I have NumPy. All right, so what we're gonna do? We're just gonna sum. All right, I can do right here. Let's say I know they have NumPy, and what we need to do is np dot sum accounts axis equals 1. All right, and then dot max. Not sure. Let's try this. Oh, I should return this. My bad. If it's not right, I need to turn on NumPy for this. Oh, I think that's good. Yeah, I think that's good. Yeah, that should be sufficient. Yep, it's sufficient. Okay, so of course, let's do it without NumPy, right? But NumPy is slow. Not as NumPy slow. It's just, I think it's just the overhead is bigger, so that's why it's slow. But anyway, so we can do. Oh yeah, that's without NumPy is also easy. We can just return maximum for row in accounts and some row. Yeah, we don't need NumPy for this. This is equally simple. All right, I'll run this. Yeah, this shall be faster. Bare bone Python. There is even faster method? How do you get faster method than this? Alright, what are this method? 56. That's the same. That's the same method. Yeah, it's the same. So nothing more to see here. $16.72. Seems like a contest, right? Yeah, nothing to say. Let's see what the solution says. Yeah. Good job for the month. Alright, so we're done with this. And let's go back to the problem. We have. Alright, so we know how to solve this. We need to go from right to left. That's what we need. We're gonna go from the right to left. Hold on. I need to handle my. Alright, so we're gonna go from right to left, right? So this one passes, but it's not the best one I can do. What I want is something faster. Alright, so this one is we will we'll handle the hash from right to left, because that way we can avoid division. Division in modulo is complicated. If we go from left to right, if we go from right to left, what is it called? Rolling hash, right? Rolling hash only requires minus and multiplication. Multiplication, which both has modulo version. Right? Okay, so we're gonna go this first. Again, we're gonna avoid using the times, right? So we're gonna call sum as a total sum, and we have this sum plus this is not to k. We need to go from len s minus 1, right, to what? To len s minus k, right? Oh my god, minus k. Len s is to the length minus, let's say we have 3 minus 2 is 1, right? And if we go minus 1, so 0, 1, 2, 1, we cannot reach it, so it has to be minus 1, right? It has to be minus 1. So it'll be 3 minus 2, if 1 minus 1 is 0, that's why I can hit 2. Okay, so when I hit first the k here, and when we hit it, ew, I do have to compute. Wait, hold on. If we go right to left, and every time we minus and then multiply, yes, but this is not right. I am going to go from here, and then I'm going to go from here to len s. Yeah, otherwise I have to go down. We don't want to go down. minus k. Is that true? So if I have three values, minus 2, 3 minus 2 is 1, 0, 1. Yeah, so from this to this, 1 minus this. Yeah, and then is it cool, right? Is it cool? So once we're done, right? Once we're done, do I have to do this? So starting with 1, and then times powers 2, and powers 3, and then the last one after we're done, it times power and then come out. So we have to reduce it. Okay, this is fine. This is fine. And the cache. I think this cache is fine as well. I think it's fine as well. Oh, hold on. I need to modulo everything. So it's going to be this modulo this. So sum equals this, plus, 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 and at the end, sum this modulo equals, so modulo again, right? Oh, that's fine. I can modulo here. Yeah, I can modulo here. That's fine. And then the cache. Yeah, I'd like to compute the cache first. So when I do this, I don't have to compute every single time. It makes sense. And then this is fine. And this has to be j larger equal to 0. Right? So we go into the left. And where is j? Right? So j need to start from len s minus k. Right? That's what start at. And then the first thing j does is minus equal 1. And then what we need to do is sum. We're going to plus. No, we're going to minus something. Minus what? Minus the end. Something at the end, right? Minus something at the end. With this power, right? Minus. So we're going to do. Hold on. So we're going to do. I don't like that. How about this one is char I plus 96, right? And then I can say, don't need this one, is sum minus cache, right? Cache what? Cache s j plus k minus 1. Maybe. Okay, let's see. So if it's 0, 1, 2, j start at 1, right? And j 1, 2 is 0. So I want to minus 3. So 0 plus 2. 0, 1, 2. So we don't minus 1, right? So we remove the last. Cache this. Yeah, it's times this. So we remove the last. Oh. Hold on. So this has to be modulo. Mod. Okay. So we'll minus this, right, and then plus modulo, just in case it becomes negative. So we're going to do this, and then we're going to times power. Right. So remove the last one, and then I times power. I times the power. Yeah. And then we plus the front. Now the front is just going to be ord j, right, minus this. So this will equal to this mod modulo, and then here we don't have the mod, right, which now I realize I have to modulo here. So we say sum equal to modulo, and no, we have to go through every single one. No, we have to go through every single one. and we have to record, right? So we're gonna have to say first one. So res, right? Res equals to what? Res equal to j. Okay, res equal to j. And for j, blah blah blah. Sum is this, right? And so if sum this is equal to hash value, res equals j. So blah 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 blah. Once we're done, we return. All right, let's try to see if this one's correct. Yeah, this is correct. I knew it. So I'm just gonna put it here. Okay. Oh, we got fail, fail, and fail because of what? I return. Oh, j res plus. All right. So this is hopefully this is faster. All right, let's try this. Lots of modulo. Ha! I don't know, man. Oh, we got a wrong answer. What? I got a wrong answer. Hold on. This is frustrating. We got a wrong answer. Okay. Not enough value to impact. Sure. I forgot to put the expected. All right. I'll comment on these and try to see what happened here. Is it this add modulo has issue? So minus cache, right? And minus cache and then plus a modulo just in case it's going to become negative. So we do that, and the whole thing and a mod modulo. Hold on, maybe I need to like times power. Maybe I need a modulo here and mod here. I just don't know where I need to modulo it. Alright, let's go back to the start. And then plus this times this, right? Which just times this modulo. So everybody modulo. This is fine. Sum plus equal to. At the end, sum also modulo. That's fine. And then this is fine. I times large P. This should be fine, right? This times this power, because that's the thing we need to minus. Right, and then j minus 1, so we're gonna remove j plus k. Because we start is this minus 1 plus k as the last one, right? So we remove the last one. And then the remaining times power. And I need to modulo the whole thing. Which is fine. Unless I cannot plus modulo here. and now we plus odd sj minus 96. Yeah, that's the cache. Okay, so maybe what we need to do is, I don't know, man. Minus this times power. Let's just take a look at the sum. What we're looking for. We're looking for a 7. We have a 7. Look, we have 7. We got it. What happened? Hold up. Let's print res. Yeah. So when we come out, the rest is 4, right? Rest is minus 1. What? What? Right? Sum equals to hash. So rest is 4. And when we come outside, how does rest become minus 1? Well, j is minus 1. Sum and j. Sum is 7 and j is minus 1. Hold up. It has to be larger than 0. Ah, I see. It should be larger than 0. Yep, it should be larger than 0, not larger or equal to, because I do the minus 1 here. And then j becomes 0. And then that shall be the end of it. Wow, this problem is just so tough. No way. Take that long? What? What? How? How? It didn't make any sense. I I, I don't know. How is this one? If this can pass, I'm out of ideas. Like, why? Maybe we don't do modulo here? I don't know, man. Alright, I don't know. I have to check. I just constantly I got hammered. There's a TLE again. I already go from right to left. I did traverse it backwards, but it just kept got arrow on me. Alright, what is the thing that I didn't do correctly? Okay. How? Current times P. Okay. I see what you're doing here. You didn't do anything special though. You didn't do anything special. Current minus value times pk and modulo. Maybe Python can handle this. How this one pass? All right, so this basically just does everything in one loop. Maybe how about I remove this? Would that be faster? Like, don't do this. And maybe also don't do this. Okay. Okay, let's reduce the number of modulo we do. Like these modulo we have to do, right? And we have to keep this equals this modulo, every value modulo, every value modulo. We added it and then modulo. So this equals plus equal. Hold on. So what you're saying is equals sum this plus, right? I plus it and then modulo. That's guaranteed. So I don't have to do this, right? And then this is fine. And this is also sum equals, okay? Let's try this. It's going to reduce the number of modulo we have to do. Does this make it faster? If it's still not working, then it's the cache. Seems like this is not working, man. Yeah. Okay. What else am I missing? Current times P. Right? Current times P plus the new value. and current minus. And here I have the original. Then we simply say current times P plus split it up, split this thing up. Okay, so how do we split it up? I say sum how about we still modulo here? Okay, we still modulo here, but we change in this one. We say minus cash at the end. We say sum plus power, right? And then I don't need this. So sum times power plus this thing, right? And then minus cash s j plus k. Oopsie doozy, that is not correct. If oh that is not correct. It times power, right? It times power plus this is the same. It times power plus this, and I modulo it, and then this one I'm gonna minus minus this and then modulo, and I have this one already modulo it. Well, already modulo it. Am I showing the modulo again? If I need a modulo, then I just don't modulo here. Or I just do this modulo. How about that? Okay. This one pass. So I kind of swap things around. Okay, let's try this one. Still no good. Okay, let's ditch the cache and then compute it fresh every single time. Alright, yeah, still no good. So let's ditch the cache. Right, let's don't cache it. And I just say instead of cache, I'm gonna say just ord sj plus k, right? Minus 96, okay, times large P. So we don't worry about this caching thing. So no cache here. Now we run. Okay. Try this one. If it's still not good, we're gonna just do the official way. Yeah, no, I don't think so. Okay, that's fine. That's fine. Let's just, I think that's the last one. Rolling hash. No, it's not the last one. There's still a lot more to go. Okay. That's fine. So what do? We have a sum, right? And power. large P. And we can call pow, right? Power to the K. No, what power to the K? Power to the K. Yes, right, power to the K. Wait, hold on. PKM. Wait, what's PK? What's pow? What does this function do? Python's pow function. Oh, ow. You gotta be kidding me. Hold on. I did not know that. My goodness, really? Oh my, hold on. Hold a sec. We modulo it. We modulo it. Are you saying we're gonna say this modulo equal to modulo? That's the part I didn't do. Okay. And how about like also cache it? Hold on. Don't cache it. Don't cache it yet. Let's try this one. That might be. So the large number. This I can modulo it. I understand this. I understand everything, but actually I don't understand everything. So this one we modulo, and this one needs to modulo as well. Are you saying the modulo can happen anywhere? It doesn't matter. No, this is not working. It's still not working. Like a modulo it is still not working. Okay, rolling hash. So official rolling hash, we have large P equals power. So power to the K and with modulo. Okay, that's large P. And then we're gonna say is for I in range from the back to the front, okay, len s minus 1, minus 1, right? And then sum equal to every time is previous sum times power plus the new one, yeah, plus ord si minus 96, and we're gonna modulo, okay, and we say if let's do this. Let's do n is len s, right, and then we just call it n. And we say if I plus k, right, I plus k. What's I plus k? I plus k is larger or equal to example k equals 2, and then there's 1, 0, 1, 2, right? 1 plus 2 is 3. But in this case, I don't minus. So when do we minus? 0, 1, 2. I don't minus 1. I should not minus. It's a 0, right? 0 plus 2. 0 plus 2 is 2. and that's when we minus. So show larger or equal to n minus 1. Right? If it's larger or equal to n minus 1, if it's larger or equal to n minus 1, so I think this is larger or equal to n minus 1. If that's the case, that means so I plus k. So I go 1, 2, right? Wait, hold on. I'm confused. 0, 1, 2. If I'm in a 1, 1 plus 2 is 3. 3 is larger than k, but it's not larger or equal to. So this we still add, but if it becomes 0, then we need to kick 1 out. The first time we kick 1 out should be I plus k minus 1. Right? I. So what we want is I plus k minus 1 is the last index. If this last index is smaller than k minus 1, no, smaller than n minus 1. So it's I plus 1 smaller than n. It's I plus 1 smaller than n. Right? If I plus k is smaller than n, that makes sense. Then we need to throw away. So equal to sum minus the last one, right? So minus this times large P. And then we also modulo. So this is going to be board S I and J I plus K. Right, I plus K. I plus K. Yes, because I plus K minus 1 is the smallest. So it's I plus K and minus 96 times large P. And after all done, then it's the same thing here. This, rest of this. Okay, let's run this. J is not defined. Of course J is not defined, because there's no J. How is this one so much faster? I don't know. I mean, for one thing, we do this, right? This is important. We get a large P, and then this is the same. Hey, this is the same as what we did in previously. Sometimes. Then we do modulo every single time, right? We do modulo every single time. Ah, I think I know. This probably has some optimized way to handle, but once I manually compute to all the power and then do modulo, that's a giant value to do modulo, so that probably costs a lot of time. And because we're going here, this is just the same. Times minus modulo minus times modulo. I suppose this is the correct way, right? Correct way to write rolling hash. Yeah. So we don't have to pre-compute anything. We just compute along the way, and we need to do the modulo trick here, okay? And then we just start from the back, gradually building up, and every time times power plus the new thing and then minus the old thing times the large power. And then, alright, yeah, that will be it. That will be it. Terrible. Still terrible. And we still have one more question to go. We'll see if we have time tonight. Alright, I'll see you guys tonight. Adios.